take them down and take them down and take them down. As you look, the whole room explodes.
Thank you.
Take them down and take them down and take them. As you look, the whole room explodes.
Hey pal, his name is Tim Messerschmidt and he's going to talk today about how to unleash the Kraken. So give a round of applause.
Thank you.
And by the way, our official hashtag is DevconTLV, so feel free to use it, feel free to tweet all about it.
Nearly done. All right, so that was a really nice intro saying my talk description sucks. Thank you. No, I'm kidding. All right, so thanks again for the introduction. Thanks for having me here. My name is Tim Messerschmidt. I just flew over from Toronto, Boston, and Berlin. I'm not really sure anymore. And so my speech is mainly about Kraken.js, which is a JavaScript framework that PayPal released recently. But I don't just want to purely focus on that framework. I also want to tell you why we actually thought about going that way, why choosing Node.js, and a bit of our history, because I think it's mostly interesting to see how companies, and especially large-scale companies like PayPal, tend to switch over technology. So, as I got introduced already, I'm heading up the European Developer Evangelism team. My team is basically responsible for speaking at conferences and collecting feedback from you guys. Also, we run a lot of hackathons, and my PC just turned off. That's weird. Well, then we do that without slides, I assume. Just give me a second. Ah, there we go. It's back again. So that was not the best start, but we should be up and running in a second. All right. So I think the best stories usually start with the background. And in PayPal's case, that's basically a story of technical debt. That's usually the moment where you want to hear sad music and the whole thing grays out. In my case, it's me telling you a bit about our background. So PayPal is obviously a company that's not that young anymore if we think about the whole internet age. We've been founded originally in '98 under the name of Confinity. There's been a lot of changes. They got acquired by eBay. X.com was in between, which was a company done by Elon Musk, which you probably know from Tesla. So a lot of stuff happened, and as most of the companies that exist since not just a few years, they usually end up with not just one technology stack. There's usually a bunch of different stacks for different reasons. Some of them is because former engineers left the company or new engineers joined the company and they just started something new. So looking at our application stack, traditionally we have two stacks available. The first stack is C++ and the second one is Java. And normally I give this talk at lots of JavaScript conferences, and that's where you see people shivering. Some people leave the room because they start feeling sick. So can you raise a hand if you're a Java developer right now? All right, don't fear to raise your hand. I'm a Java developer too. C++? Okay, still some in the room. So you see, even nowadays, with now 2014, it's not purely C++ anymore. It's not purely Java anymore. And Java used to be incredibly popular. So nowadays people run Ruby, they start running Node, they run Python, and new stuff like Dart, like Go, There is so many cool new server frameworks, and obviously all of those exist for certain reasons. So let me give you an example of issues with our old stack. So that used to be PayPal in 2002. It's one of those really horrible sites from back then. And you know, the issue was if you wanted to change the text with the number of users worldwide, which is in the lower left corner, that actually took 6 weeks to deploy. Yeah, 6 weeks. And obviously changing a text was not an issue, right? Because changing a text is obviously super easy. So it was really, the whole site was never ever built for rapid deployment cycles. It was never built to be updated as often. So basically at that time, PayPal, the whole product, not just the website, but also the API and anything behind that, was released every 6 weeks. It was one fixed deployment cycle. And we didn't break that cycle unless there was any big issue. So whenever you want to change something and you have to wait 6 weeks for that change to appear, I kind of feel like this. Does anyone still remember Indiana Jones and the Raiders of the Lost Ark? So what happens, just to give you a quick explanation, Indy wants to steal the golden idol, and he has this bag of sand in his hand. And he doesn't really know how heavy the idol is, but he knows if his bag of sand is not heavy enough, and he removes the idol and replaces it with that bag, he might probably die. So at least I personally feel like that's how I would have felt as an engineer back then. So probably not the best way and not the best advice. Don't stick to that. Nowadays, gladly, we have better processes for that, and that's where I want to go to now. So we had those two different worlds. We had our production stack, and I told you about 6 weeks of deployment cycle, about C++ and Java, which is all probably okay to build large-scale applications. But nowadays, there is those things like Lean UX, there is Agile, there is all those kind of things where you want to do A/B user testing, and you want to get quick feedback and iterations on your products. So on the prototyping side of things, instead of building our apps on C++ and Java and using all this legacy code that we had, we've been running Bootstrap, we've been using Bower, we've been using JavaScript templates, basically anything that supported handlebars, like Mustache, like Jade, like anything that people basically wanted to try. And what we did is basically, we did the first beta servers or staging servers with user testing. So we invited people to try out the products, and once we had enough feedback, we ported that JavaScript code and anything behind that into our legacy code. So obviously, we were still bound and had to run this really horrible stack. So for us, that was obviously not the one solution. So at that time, we had even 3 stacks running. So again, C++ with XML layouts, we had Java with JSP files, and then we had Node.js as different prototyping environments. And that obviously ran on JavaScript. And for us, the big one advantage that we saw is if we have our front-end engineers and the back-end engineers talking the same language, obviously it's easier for them to just link up applications, spin up new prototypes, and bring the whole thing at some point to production. So for us, it was quite clear we had to move away from Java. So the big reason why we did that is, originally at PayPal, we used to write basically the whole applications in Java, which doesn't just mean the backend, so not just JEE or Spring. We actually wrote even CSS, HTML, and JavaScript in Java. And that's horrible. So obviously that was not the way to go. So people started to decide once JSP came out that we shouldn't write everything in Java, but in JSP. So we had those templating files. And I don't know who in this room ever touched a big JSP file. You have this big issue that there is a mixture of JavaScript, HTML, CSS, and Java in the same file. So obviously that didn't really solve anything. And then we had this proprietary solution based on Java, which was basically a Spring clone / add-on / framework that we called Spartan. So Spartan used to be used to basically build PayPal's UIs. So anything that had to look like a PayPal app was leveraging Spartan, our framework, and it had advantages, like you could easily reproduce the whole look and feel, but also big issues like people had to actually learn Spartan because they had to get used to a whole new framework, and it was proprietary. So gladly enough, there was a big push for open source within our company. And I can basically give you 3 big reasons to go for open source for basically anything. The first reason for me is obviously your engineers will have far less ramp-up time than using proprietary solutions because they might already know that stack or they may know something that is really close to it. So obviously a big advantage because they can play around with that before they join your company. Now the second reason for me is instead of building your applications with proprietary solutions, people have to learn your solution first. They have to build the framework and not the application itself. And obviously there is people that actually have to upgrade your solution, they have to update it, they have to bring in patches and all that stuff. So it's far more difficult to maintain proprietary software than open source software. And the third and last reason, for me at least, is community maintained work and basically community pushed work is usually at least on the same level of professionality and efficiency than proprietary solutions because far more people help to achieve at least the same effect. So basically, you can concentrate on your products. And that was one of the few reasons why we started to do open source at PayPal. Now, obviously, we had to start doing rapid deployment and rapid development because we wanted to stick with what our engineers that came into the company were used to. So, as I mentioned, we've been using Bootstrap for the front end, and we were huge fans of JavaScript templating, which means we've been trying out a lot of different solutions. And at some part, we started to like Dust.js, which is a solution that was originally published by LinkedIn. And PayPal at some point started to commit on this one templating engine, which is basically not a decision against others. It's just a solution that we tend to like. And now, obviously, we had those 2 other stacks, not just the Node stack. We had Java and C++. But still, we wanted to play around with JavaScript templates. So what we did is we founded one project, which we call Project DeLorean. And if you have seen Back to the Future, you might be familiar with basically this one car which is able to do time jumps. So what we do is we injected V8, the JavaScript engine, into our C++ stack, which was fairly easy. And we're able to run our JavaScript templates natively on our C++ stack. So instead of sticking to XSL or XML for templates, we could just use the same templates. Now on the Java stack, that was obviously a bit more complicated because V8 is not native to Java. So what we did is there is a cool open source project by Mozilla called Rhino. And Rhino uses Spring resolvers, so view resolvers in Spring, to basically backport JavaScript in Java. So you can execute regular JavaScript on your Java stack. And that's how we still maintain JavaScript templates on that stack. So the nice advantage is obviously we don't just have a new stack and leave all the other stacks behind. We can push the same cool UI features to all stacks at the same time. So that is basically the situation that we are in now. So we have the one stack, which runs with Java mostly. We have the Node stack, which is obviously fairly easy to push to anyway. And then we have our prototyping stack, which runs on Node.js anyway. And now, obviously, having Node in the prototyping stack is one thing, but bringing Node to production is another thing, because Node is still fairly young, And usually when you tend to use new frameworks, new software, or even new stacks, you run into a lot of issues. So I want to share a little story of how we did that. So when we tried to use Node in production, we didn't just want to commit on a tiny, tiny feature, like, I don't know, the help center or whatever at PayPal. So we decided to go for a big part of our application, which is the checkout page. So whenever you commit on paying with PayPal, you get this window that basically asks you to enter your email address and password. You log in, and then you choose, if you have multiple funding sources like a credit card and a debit card, how you want to pay, and then the merchant gets paid. And this one application creates 3.5 billion of revenue each year. So it wasn't just a minor application, it was basically an essential part of what PayPal does. And we call this project Hermes, like the god of agility in mobile. And what we did is basically, we had a few brilliant people joining our company, like Bill Scott, who used to run engineering at Netflix. We hired Doug Crockford, which is one of the gurus of JavaScript. And those people sat down and started thinking about JavaScript. And within the first 3 days of those people coming together, they were able to start off the first prototype because they didn't do any legacy code. They just wrote a whole app from scratch. And again, Node, Bootstrap, and other open source. We've been leveraging Express back then in version 2. We used Encom for configuration. So they basically used a lot of the stuff that's around anyway and just tried to build an app. And that app was actually so successful that we started to build the actual version of it. So what we did is, again, for historical reasons, last year in January, we decided to not really risk anything by having a Java team building the app and a Node.js team building the app. The Node.js team was about 2 people, the Java team 6 people. And the Node team took about 2 months to integrate against our session services, against our key store, against the databases, against logging services. So basically all the stuff that you need to integrate into the company infrastructure. So after 2 months, they could finally start to build the actual application. In June, they caught up to the Java team, which was 3 times the size of the Node team. And we ran a whole suite of tests against the application, and they both worked. Both passed alike. So for us, that was a great sign to commit on Node because our teams were far faster than the Java teams in that project. Obviously, it's a bit of an apples to peaches comparison because one guy had to use a proprietary solution. The other guys were able to inflate a lot of open source services. Now, this is the situation that we are in right now. We decoupled the UI code from the whole stacks, and we are able to run the same UI on all 3, which is great for us. Now, JavaScript templates obviously bring one big advantage for us. It's mainly we can basically render the same UI both on the server side and the client side. And we don't just have to commit on that when building the app. So we can actually decide these things dynamically based on load, based on connection. And what we do is whenever you go to paypal.com, the first site is always rendered on server side. But anything after that, anything that's basically dynamic, we can usually start deciding what we want to do, and that's a great advantage for us. Now, I want to briefly go into performance. I'm not going to talk about that a lot, but you can see now 2 comparisons. The first one is our Java stack that we used with the application I told you about, and we ran a couple of benchmarks. And the throughput here is based on 5 cores on Java. And basically, the throughput is not too bad. It's okay. But if I start showing you now the same app with Node, the throughput is far better, and it's just running right now on 1 core on Node.js. So one app with Node.js is already far faster than 5 cores on Java, just by basically getting rid of all the proprietary stuff by rewriting, obviously, the whole app, and by having the speed of native execution. So what we did is, as I said, we've been using a lot of those services that we needed to run our infrastructure. And instead of just having weird proprietary solutions, We deployed an NPM server locally at PayPal to inflate those services for all future applications. So whenever we want to use a PayPal app now that runs on our Node stack, we just run a lot of NPM commands like npm install monitoring, logging, security, and within 15 minutes you're up and running. And that's something that I think is really, really great. So obviously the team started adopting Node and we found a lot of best practices, and that's when we started and decided to release the Kraken, which is a convention layer based on our Express framework. And what we do is basically we work a lot of things out that the community usually has to do manually. So it's a suite on top of Express, and it is basically pre-configured with best practices. One big example is usually security, like CSRF protection, X-frame hijacking, and that stuff. There's always some solution around, but people usually don't integrate it because it doesn't come out of the box. So we've been using Dust for templating. Again, it's quite logical why. We've been using Less for CSS as a preprocessor. Require.js to basically load all our JavaScript modules. Cron for running tasks and doing the UI updates. And it basically comes with a lot of configurations that helped us. And the big issue is basically if you run Node within one team, you have one configuration. But as soon as you start running Node within a bunch of teams, everybody does something different, right? They define the cookie parser before the body parser. They do the routing kind of different. Some of them set up the database connections differently. So we wanted to have one way to go, one certain structure for our applications. So the structure is fairly easy. There's a configuration, there's controllers that we like to enforce, models, obviously, where you have your data objects, templating, and locates. So Kraken supports different locates out of the box. And I'm going to showcase that in a few seconds. So I think the most interesting part is basically there is 4 big modules that basically are part of Kraken. Makara is being used for the internationalization. Then there is Luska, which is a security plugin. Adaro, which brings the Dust.js support. And Kappa, which is your local NPM proxy. So you can either deploy NPM, the Node package server, or Node package service on your local machine or on your corporate level. And since it's a proxy, if you don't have an npm package installed over there, it still falls back to npm.js.org. So this is about the usage for Makara. You can basically plug it in manually. So even if you don't use Kraken, you can still benefit from the localization. And what you do is you have a provider that's being basically provided with different languages, locates. So you have EN-US, DE, EN, ES, and stuff like that. And it is leveraging different property files with a bunch of different data structures. It's not JSON syntax, but it's basically something really simple. It's basically a key value pair combination. And it is able to monitor, basically to show lists, to show maps, and subkeys, and a few different other data structures that you might need. And now, if you throw in values in there, you have multiple files that are being reflected by a data structure. And you can just start using Makara like that, which is fairly awesome, I think. Now, Luska, again, it comes with all these protections against cross-site request forgery, X-frame hijacking, so people cannot just frame your website and steal user input, output escaping, so that people don't just drop your tables, and content security policy, which I think is quite awesome as well. And I think content security policy is also a topic that also deserves its own talk, so please read into that topic, it's awesome. So the configuration is made just in a JSON file, so you can decide which features you need, but Luska is coming with sensible defaults. So you don't have to read into that topic too much if you just want a sensible out-of-the-box protection. And especially the CSRF protection and the XSS protection is fairly interesting, because all you do for your forms is basically providing one of those hidden fields with the CSRF token. And the token basically just makes sure that nobody changes data without you doing that. And for me, as a security guy, I feel so good about that. Now, Adaro, it's fairly regular. You just set up a new view engine, and that's it. And you start doing templates with Dust, which don't really have too much logic in it. But it comes with a cool function like partials. It allows a few things like sections, so you can iterate over data models. But it doesn't really know about its content. So you cannot say, take the fifth object of something, take the third object, do this, do that. It just comes with a bunch of conditionals. So it's either you take the whole thing or you don't do anything with your data. And again, Kappa, you just install the package and you start the server with a JSON file, and that's it. So the configuration is extremely easy. Now, configuring Kraken for me is something that I really enjoy because you just have those JSON files. So if you want to change something, you don't have to fiddle around in one big file. You just use your file, you just change a few values, and that's it. If you want to have different setups for the production stack and the prototyping stack, you just use the node environment variable and change that, and it picks up that change. And if you're looking at the setup, the app.js file, which in Node project usually is the index.js file, is fairly lean, and it comes with a life cycle. So you can set up things like passports, authentication services, databases in one of those methods, and you don't have to clutter up your code. And it comes with a generator, which is based on Yeoman. So whoever does web development nowadays at least tried Yeoman, and I think it's fairly cool. So what you do is you just install the generator for Yeoman and execute Yo Kraken, and you get your application inflated. I'm going to show that now. So what you see is it's just an empty project that I start. I define a name. So we go with that. And I just define a few things that go into the package JSON file. You can choose which templating engine and CSS engine you want to have. And it starts just scaffolding the whole project for me. Now it uses npm to get all the packages. It gets some stuff via Bower. And we should be done in a second or two, or 3. Okay, you can start calling me a liar. It takes even more. There we go. So we go into that project and have a look at it with Sublime. What we see is it generated a controller, and you see that the routing logic actually is part of the controller. So the index file doesn't know about the routing of your application. That's something that we try to do, because usually you end up with a big mess, and it usually doesn't make sense to have all the logic in one file. So we try to distribute that. The models are being generated for the same index file. You have the localization in there. And what we do now is we create a new controller, which would be something like users. So you want to return a lot of user data. And we add a localization for that. So I add support for German. And what we see now is we have a new localization over here. So we change that string into Guten Tag, which means hello. And now in my controller, I just copy-paste that it is supposed to use German. So obviously, if you do that not just in live coding, you would do that slightly different. So you see for the locales, I have my user file with Guten Tag, and you have over here hello. And now if I start the whole thing, and I go to my Chrome, you see the index route says hello, and my users file starts saying Guten Tag. And that's basically localization out of the box, which is pretty cool. So I have to end now, so fairly quickly going into what's coming. Kraken 1 started to adopt Express 4, so routing got a bunch of easier. You can do now stuff like /users and /users all and /users new in the same controller, which is kind of nice. And we are adding support for A/B testing through specializations in the templates fairly soon. So, giving you a quick summary, our team size is reduced a lot. So, between 1/3 and 1/10 of the Java teams is being needed for our Node apps. And the nice thing is we can bring all those Java engineers to JavaScript. They adopt that language fairly easy. We doubled the requests in our application fairly easy through just using the new frameworks. The average response time decreased. The lines of code in our projects are far smaller. The development time is much faster, so it's double as fast. And we are able to use JS both on front end and back end. So that's why we are mostly looking for full stack engineers. And now I want to thank you. And since I ran out of time, please, if you have any questions, come up to me and we can just have a chat. Thank you.